Okay, again, some of the notation is what we have to see. First of all, so the union of sets A and B, A union B, consists of all elements in A or B or both. It is represented by the entire region of these sets on a Venn diagram. So if I have a Venn diagram, okay, this circle represents A, this circle represents B, this guy right here is A and B. Now the best way to remember the notation, this looks like an A. If I put a line across, it's an A. That means and. Okay? So that is the part of the set that's shared between the two. So that's A and B. A union B means all of it's in this and all of it's in that. So a perfect example to look at is if I take a die and I look at the even numbers and the prime numbers. So give me the list of even numbers on one six-sided die. 2, 4, and 6. What are the prime numbers on that? 3 and 5 is correct. 1 is not. That's a fallacy that nobody really ever remembers. 1 is not considered an actual prime number. They always say it is, but it isn't. Because it has to be something that's multiplied by itself and 1 as the only two factors. Well, 1 and 1 are the only two factors. 2 is a prime number. That's the first prime number, right? So what do these two sets share? They share a 2. So I stick it in the middle. I should have done that first, and this is what's left. Okay, so if I'm asking you for what is even and prime, what do I get? Just the 2. If I'm asking you for even or prime, 2, 3, 4, 5, and 6.
So what is it upside down on your knee?
And
So,
this looks like an A. I drew this across, it'd be an A. That means and. That means it's in A and in B.
Yeah, it's the other one, the U.
This is the U, means union or or.
Oh, yeah. That's
Okay? So, what would this mean to you?
without, like the dash thing means without. So even without, even or prime without.
Okay, you're on the right track. What is the answer then?
One.
There it is. Okay, so that notation actually means even or prime, but we don't want either. That's not even or prime. What is the one thing that's not even or prime? One.
I guess.
It's the only one that's, no, we're talking a six-sided die. Right? So the last of it would be to do this, and you put your 1 down there. If you're to actually finalize that off, if need be. Okay? Does everybody understand the notations? All right. The intersection of sets, we've done A and B already. Okay. These two things right here, make a note of them. The principle of inclusion and exclusion states that the number that are in A or B, okay, so the number that are in set A or set B, we can find it by, all right, I'll leave out my example here, okay, so looking at this right here, the number that's in A or B is all of A, so all of them that were in A, plus all of them that were in B, minus the one in the middle. So basically what that is saying is, I don't want to count the number 2 twice. That's what that's saying. So if I look at A or B, okay, so how many, oops, this is asking you for how many were in A or B, okay? So how many even numbers did I have? 3. How many prime numbers did I have? 3. And I have to subtract the one that was shared, which is 1. Right? I'm asking about the amounts now, not the actual value, but the amounts. So there's 3 in this circle. There's 3 in this circle, and I subtract the 1 in the middle. So how many terms do I have, or values do I have? I have 5, which is what I have here. 1, 2, 3, 4, 5. Okay? So this is called the principle of inclusion, which means that if I do A or B, to find the number of A or B, I find out how many I have in A, how many I have in B, and I subtract the number that's the same. Okay? Do we follow that? It's not very complicated, but again, we have to get our notations down. Any questions so far about this? Basically, so the N in front always says, how many do you have? It's not asking for what do you have in there, it's how many do you have in there. All right? Okay. The number of A union B, or the number of A, given that you know what B is, plus the number of B, given what you know A is, plus the number of A and B, where A given B indicates the elements that are in set A but not in set B. So this is just another way of writing it. I don't use this one at all. I just use the first one. The first one to me makes the most amount of sense. If sets A and B are disjoint, what does that mean again? I asked you. Nothing in common. So then if I was asking you then for this, how many were A and B, what would I get? All of A plus all of B, and then that's it. I won't have to subtract anything because nothing's in common between the two, right? So that's if you have disjoint sets. This is if you have something in common between the two. This is if you don't have anything in common, which is called a disjoint set. Okay? Again, Venn diagrams. Put in your middles first. Whatever's shared, you always put them in first. Okay? Take a quick look at the example. Following produce is sold at a farmer's market: corn, apples, onions, beets, carrots, parsnips, tomatoes, asparagus, beans, watermelon. Determine the number of food types of each quality that are round, that grows underground. Okay, so I'm going to set up this. This is going to represent all the round fruit. This is going to be the underground. So out of that list, which ones are round and grow underground? Apples don't grow underground.
Beets. Oh, sorry.
What does?
Beets.
Beets, and what's the other one? Onions.
Rory, carrot. What shape is a carrot? Carrot's a cone.
Okay, onion and beets. Both grow on the ground, both are round.
Apples?
You do a lot of gardening, don't you?
I wasn't listening.
Okay, so now, what's left for over here? What's round but doesn't grow underground?
Apples.
Apples. Hey, nailed it.
Watermelon.
Apples, tomatoes, watermelon, and is that it?
Parsnip. Grow in the ground. Yeah, carrots. Third column.
What's that?
They're like little white carrots. But they're not. They're tasty.
Okay, so then that takes care of that. What's left?
I thought parsnips.
Carrots grow underground, and so do parsnips. Okay. So far, so good. What is neither grown underground or round.
Asparagus.
Asparagus.
Apples are before.
So beans, corn, asparagus. Okay, so I better put my box up. That includes everything that's inside the question. Okay, so how many round ones do I have?
5.
5.
Whoa.
5. How many underground?
4.
4. How many grow round?
Excuse me, Mrs. Tara Martin to the office, please. Mrs. Martin to the office.
How many are either round or grow underground?
No. Oh no. 5.
How many?
Round or.
Like
all
of
5, 6, 7. Okay, so when I ask you or, it's olive in one, olive in the other, minus the 2 that are shared.
Oh.
Right? So this one has 5. This one has 4. Makes 9. But we got to minus the 2 that are right here. 7. Look, if you don't like to use the formula or the equation, 1, 2, 3, 4, 5, 6, 7. Count it. Count it. Right? Simple. Which ones are neither round nor grow underground? How many of those are there?
3.
3. There's 3 of them. Okay. Spend too much time with them. Okay. Let's look at 3.4. This is meat and potatoes today that we have to, yeah. Okay. So today is our first look at
It's a really good circle.
Which one?
The first one that you made.
Yeah,
Oh,
the
yeah.
second one's a little wonky.
Alright.
We tried, so
Third
now
one's
it's
not bad. It's the, you know, it's the soft side.
Okay, so we have A, B, and C. Okay.
Wait, I got to draw these.
Now,
Oh.
to represent 3 intersecting sets with a Venn diagram, use 3 intersecting circles, which we've done, and the Venn diagram shows. Okay, so A and B and C. A and B and C. What does that mean? Where do I find it?
Right in the middle.
Right in the middle. So this is A and B and C. Right? Okay. If I look at A and C, A and B, B and C. Okay, so just explain that to me in words. What is A and C?
It's where A circle and C circle like intersect without the B circle being in there with it.
Okay, good. So that would be right here. Agreed? And then I got right here. That's my B and C. And there's my A and B.
Wow.
Make sense? Okay. So then the last of it then is A, B, C with no intersection. So that is just that, that, and that. Okay? And that's the order in which we solve these. That's the order in which we solve these questions. We start from the very middle and work our way out. Okay? They're not hard if you get the information given to you. It's if they leave out one piece of information and then we have to solve it. So that's the next part we have to look at. Okay? So the first thing we're going to do is let's look at the example. And then I'm going to explain, I probably have to explain it anyways. Okay, page 72. One of the things that you have to add to your sheet is that bottom bullet on page 72. So it says the number of the number of A or B or C. Okay, this is one that gets complicated for some. All right, this is where we tend to have a problem. So what am I asking for? I want to know everything that's in those three circles. That's basically what it is. How many do I have in all three of those circles? That's what I'm looking for right now. Okay? So I find it by taking all of A, adding it to all of B, and adding it to all of C. So if I just added A and B and C, what am I neglecting to do then? Subtracting the overlapping there, right? So I have to then do that. So the next thing that I'm going to do is I'm going to subtract my overlap. So they do subtract the number of A and B, subtract the number of A and C, subtract the number of B and C. So I'm subtracting that, and that out. Okay, those overlaps, I subtract those out. But then in the very end, I have to add in, because I've subtracted all of those, I have to add in the very middle, right there. Fair enough? Okay. It's not hard. Like, it really isn't, but I can see where there would be issues with it. So I'm going to do this. Okay, let's look at my example then. All right, grade 12 math class. 25 students have a tablet, an MP3 player, or a cell phone. So 25 students in the classroom have one of the three. They either have a tablet, an MP3 player, or a cell phone. 15 students have a tablet, 14 students have an MP3 player, 13 students have a cell phone. 5 students have a tablet and an MP3 player, 4 students have a tablet and a cell phone, 2 students have an MP3 player and a cell phone. How many students have all three devices? How many students have only one device? Okay, so is there anything in there that says that it tells us how many kids have all three of them? No. So I've got a tablet, MP3, right, and iPhone, or cell phone, whatever. Like this. So I don't know how many have all three. Is that correct? Okay. So I'm going to put an X here, because I don't know that guy. It does tell us some combination of the three, though, does it not? 5 students have a tablet and an MP3. 5 goes there. 4 students have a tablet and a cell phone.
Excuse me, Mr. Wilson, to the office, please, Mr. Wilson.
2 students have an MP3 and a cell phone. So I have that. So far, so good. Okay. So now, if I look at the tablet, how many kids have a tablet?
45.
No. How many students have a tablet? Just a tablet?
15.
I have 15, right? So right now I know that there's 9 of them that are here. So if I knew that, I know that that's 15, I would then subtract 5, 15 subtract 5, subtract 4, subtract X. And that would get me how many have just the tablet at that point. But I don't know what X is, correct? Okay, how many have a cell phone? 13. So I take 13, subtract 4, subtract X, subtract 2, and then I can calculate how many have just the cell phone and nothing else, right? Okay, and the MP3 player? 14? So I take 14, subtract 5, subtract 2, subtract X, and I would find out how many have that, correct? Okay, but it can be done that way. It can be done, and then I would just isolate it and do all that. But what I'm going to do is I'm going to use this, oops, I don't want to do that. I'm going to use this equation now. Okay, so I want to know the number of tablets, MP3s, and cell phones. Okay. So, number of tablets is how many? Oh, first of all, sorry, my bad. How many, okay. Do I know what this is? Do I know how many have
25.
one of the three? What is it?
25.
25. So I actually know this. So, this is 25, because there's 25 kids in the class. So I'm going to go like this. 25 equals. Okay, my question again. How many tablets? 15 plus. How many MP3s? 14 plus 13. And I got to subtract.
2 plus 1, 4. Is that right?
Okay, so I've got to subtract. Okay?
Subtract your x plus your x plus your 5 and your x plus your 2 and your x plus your 4. Right?
Okay, so this is the number of tablets and MP3s. So just the tablets and the MP3s. So that's this and that. That include the X. Because it still has, right? It's still in this circle and it's still in this circle. So I'm going to subtract, X plus 5. Subtract X plus 4. Subtract X plus 2.
Don't you have to add your x to get the one in the middle then? Take one more value of x?
Yeah. Okay, so 15, 14, 13. X plus 5, X plus 4, X plus 2. I got to add that in. What is that value right there? Plus X. That. Okay? Now it's just algebra.
Oh.
So 25, so 15, 14, 29, 29, 13 is 42. So we got 25 equals 42 minus X minus 5 minus X minus 4 minus X minus 2, add X. Okay, collect our like terms.
31.
Okay, actually, let's start with that. Good job.
31.
Okay, so I got 42 subtract 5 is?
31.
42 subtract 5.
Oh,
35. No, 42.
42
37.
minus 5 is 37.
God.
Minus 4 is?
33.
33 minus 2 is?
31.
31. So I got 25 equals 31. I got minus X plus minus X. So minus 2X, minus 3X, add X, minus 2X. You're okay? Can somebody do 25 minus 31 in their head?
Minus 6.
Hey.
What?
X equals 3. Okay, so we go back to this now. Everybody follow what happened there? Okay, so basically, as long as you have it written out, like this guy right here, you're just following it. I just want you to understand where all of these symbols, what they represent on this Venn diagram here. Okay, so now, we go back to that. That's 3 right there. Okay? So how many tablets did I have?
15.
15. Minus 12, 3. How many MP3 players did I have?
14.
14 minus 10. How many cell phones? 13. 13 subtract 9. So how many students had just one tablet? 3. How many students had just one MP3? And how many just had a cell phone? 4. Everybody got that? You all right?
Yeah, I'm understanding it.
Okay. Okay.
I just looked at algebra.
All right. The question asked, how many students have only one device? 4, 4, and 3, so 11 of them. Okay, that's it. That's all there is to it. All right. You have today to finish off the 3 questions on 3-2. Work on 3-3, and if you get through that, you can start in on 3-4. 3-3 has got basically 10 questions of Venn diagrams with 2 circles only. And you just need to use the little equations to get you through it. Okay?
Can I work some more?
All right.
Can I take this home?
Good work. Yes.